In today's video, we are going to discuss about the logistic regression by using the Jupyter notebook, and we are going to do it with the help of Python programming language. Uh, what is logistic regression? At first, I want to tell that. So basically, logistic regression is a type of regression where the dependent variable can be represented as a category. In the linear regression, the dependent variable is represented by quantitative variable, but in the logistic regression, the dependent variable uh, can be represented by a category or um, can be represented by a category mainly. And in some of the cases, the independent variables will also be represented by categories or qualities. Now, for before diving into the code, at first I have to import some of the packages, that is numpy package, a pandas package, matplotlib.pyplot package, cbon package, and sklearn.matrix package. And we are also importing the warnings so that the warnings that will not be shown here and all of the warnings will be ignored. Okay, here this NP, PD and PLT and all of these are basically the alias that we are going to assign. This alias are nothing but a short form for the packages. This short form you can execute in the program or in the code, so that you don't have to write numpy or pandas or matplotlib.pyplot. You can just write PLT or PD or NP. It will just do the same thing as the numpy or pandas or matplotlib.pyplot was supposed to do. Now for the um, code, at first I have to load the dataset. The dataset, we have a dataset that is named upon default.csv, and I have the dataset installed. This dataset is easily available in the internet. You may find out this dataset, and it is named upon as default.csv. It is a dataset that represents that how much are defaulters and how much are not defaulters. That means if the in case of, you may see, this is the default column. Now in the default column, yes or 1 means the person is a defaulter and will not be able to repay his loans. And if the in the default column, if the value is 0, that means the person is not a defaulter and will be able to repay his loans. Okay, so this is the description of the data set. We have some another columns, that is balance and income. And if we want to see the first 5 rows of the data set, and then we have to just give default.head. By using this code, we may see the first 5 rows of the dataset. Now, moving to the next part, if I want to see the shape of the dataset, that how many rows and how many columns are there in the dataset, then I have to just assign default.shape. As you can see, by assigning default.shape, it is saying me that there are 1000 rows, 10,000 rows, and 4 columns in the dataset. 4 columns can be easily visible here: default, student, balance, and income. But 10,000 rows will not be visible here directly, but it is in the dataset. Okay. Now, if I want to see the mean values of the student column, balance column, income column, if I want to see the how many observations are there in the count column, in the default or student column or balance column or income column, what is the minimum value, what is the maximum value, and then the percentile. If I want to see the 25 percentile, 50 percentile, 70 percentile, here this percentile is denoting that how many observations are actually below 75% of the values. Okay, so for that I have to just assign default.describe. It will give me all the description of the data, starting from mean, standard deviation, minimum value, maximum value, 25 percentile, 15 percentile, 75 percentile, maximum value. Here you can see in the default column we have 1000 observation. In the student column, balance column, and income column, in each of the column we have 1000 observations. That means there is no missing value in the entire data set. That is a good thing for our analysis. Sorry for that. Now, moving to the next thing, that if I want to take the idea about the data points of the balance column and income column by box plot. For that, or for taking the idea of the data points of balance column and income column by box plot, I have to plot the figure. For that, I have to use the code, and then I will use the box plot. Here subplot is used because I want to see two box plots within the same figure, so that's why I am using subplot. And plt dot subplot and 1 2 1, that means this will be our first figure, and 1 2 2, that means it is our second figure. Now figure size is mentioned here 15 comma 5, and it can, I mean, it is just supposed to be mentioned for once only. Now for creating a box plot, I am going to use the SNS, which is the alias of Seaborn. I am going to use this SNS does box plot. And what do I want? I want the balance column. I want the values of the balance column. So for that, I am just giving y equals to default. This default is nothing but the name of our data set. As you can see, let me show. Um, I have assigned the dataset as default. Okay. The name of the dataset is nothing but default here. I have assigned the entire default.csv into this default. So this is nothing but the name of our dataset now. So y equals to default. uh, Within third bracket, I am assigning the name of the column, and I am assigning the name of the column from which I want the data points. So I want the data points from the balance column. So I am just assigning default, which is the name of the data set. And within the third bracket, I am assigning the name of the column within single quote, that is the balance column. Similarly, if I want to create the box plot of the data points of income column, then I will just do the same thing. But here I am going to assign within third bracket the income. So I am just, if I want to create the box plot of the income column, or if I want to see the data points of the income column within the box plot, then I am just going to assign the income column within the name of the data set within the third bracket. And if I just code it as plt.show, then I can see the two box plots represented to me. Now, as you can see in the box plot, in the balance column, there are some data points. The most of the data points are in 500. Yes, in most of the data points in the balance column are basically uh, within 500 to on 1200, and most of the data points in the income column are from 20,000 to 45,000. Okay. Now here we will get let's take an idea of data points of students and default column by box plot. Now if I want to take an idea about the data points of student and default column by the box plot. Okay, so here we will get an idea of how many students are actually there and how many defaulters are there. Okay, so if I want to plot both of these things together, that how many students are there and how many defaulters are there. For that, I want to, in the same function, I want to just give the plt dot subplot. That means I want two box plots, or I want two plots. This is not a box plot, basically it is a count plot. And I want to count plot is basically used for counting the values and then representing it. Okay, so here it will, this sns dot count plot will do nothing but it will count the values of students and it will plot it. Similarly, sns.countPlot default equals to default. This will not do nothing but it will count the values of defaulters. I mean the values of defaulter column, default column, and it will show it. So as you can see that in the plot we may see that here in the first count plot we are actually counting the student column. That means here 0 means the person is not a student. Okay, so there are all and here this 0 in the second count plot, the 0 means the person is obviously the person is not a defaulter. Here 0 means the person is not a defaulter. Now leading to the next topic, that and the next thing, that if we want to calculate that how many students are there in the entire data set. Okay, so that means as you can see, I am just going to assign the name of the data set, that is default, then the name of the column, that is student, and dot value counts is used for showing the for counting the values and showing the values. Okay. Now, as you can see, there is 29441, one denoting yes, that means the person is a student. Zero denoting no, that means that the person is not a student. Okay. So there are almost 7,056 persons who are not a student. Okay. And if I want to count out the value of defaulters, that how many defaulters are there in the data set, then as you can see, there are total almost uh, 333 defaulters and 9667 non-defaulters. Okay. Um, Now, if I want to normalize it, if I want to convert it into a proportion, then I have to just give the name of the data set and the name of the column, then dot value counts, and then within the first bracket, I have to give normalize equals to true. It will give us the proportion, how much proportion is students. So as you can see, there are 70% or 0.7056 proportion which are not student, who are not student, and 0.2944 proportion who are actually student. Okay, similarly, I can do the same thing with the default column. Here you can see that 0.9667 proportion are actually non-defaulters and 0.033 are the proportion of defaulters. Now let us see income in a graph and default and balance in a graph. Okay, by this we will get an idea what is the range of income for defaulters as well as non-defaulters, and what is the outstanding balance for the defaulters as well as non-defaulters. So for that, I am going to take the help of box plot again, and within the box plot, I am just going to pass on the columns, that is the balance column and income column, just as before. Now, as you can see from the balance column or from the data points of balance and income column, you may see that there are some outliers present from this. After this 2200, there are some outliers present in the data set. In the income column, there are no outliers. It is very much beautifully presented. But in the balance column, there are some outliers present in the data set. Now we will try to remove it after some steps. Okay, we will try to remove these outliers. But before that, we have to check the null values. Is there any null value present in the entire data set? For that, I have to just give the name of the data frame or data set, and then dot is null within first bracket, then dot sum and first bracket opened and closed. We may see that there is no null value present in the data set. That is a good thing again for our entire operation. Now let's remove the outliers. For removing the outliers, at first we will find out the quantile. Q1 is the 25% quantile. What does it mean? It means that 25% values or data points of the balance column are lying below Q1. Similarly, Q3 is the 75% quantile. That means 75% values of the balance column are lying below Q3. IQR, interquartile range, it is nothing but which is the values which are consistent within Q1 and Q2. All of the values which are present between Q1 and Q3 will be in the IQR or interquartile range. Now here Q1 and Q3 is basically the we have to, for finding out the Q1 and Q3, we want the Q1 and Q3 from the default data frame or default data set and from the balance column. Then we are going to assign dot quantile 0.25, 0.75. It is nothing but it is used for finding out the Q1 and Q3. That is the 25% quantile and 75% quantile. Then for finding out IQR, we have to just subtract Q1 from Q3. Then for the lower limit and from the upper limit. Okay. For the lower limit, we have to subtract 1.5 into IQR from the Q1. For the upper limit, we have to add 1.5 into IQR from the Q3 or yes, from the Q3. Now, any value lying below this LL or above this UL is a outlier. So this is a very good method of finding out the outlier and removing the outlier. Any value that is above UL and below the UL is a outlier because it is not present within the range of Q1 minus 1.5 into IQR. and it is not even present in the range of Q3 plus 1.5 into IQR. Okay. Now, although we have seen it, there are some values of balance column data points which lie above UL. In this box plot, you may see that there are some values present here which is lying above the UL. This is nothing but the UL. This is nothing but the LL. That is the lower limit. Okay. Now, we will give a look on what to do with those outliers. Now let's check us the value of UL and LL ons. UL is nothing but 2193.174 and LL is nothing but minus 545.1384. Let's find out all the values of the valence column which are lying above UL, which are basically obviously the outliers. So for that I am assigning a new variable name of I am passing my data set into a new variable called df, and here from here in df I am just giving the uh, default, that is nothing but the name of our data set, and from the default I want to extract the balance column. That's why I am giving default again, and within third bracket balance column, that is the name of our column, greater than UL. Now if I print df, you will see all of the values of the balance column which is present in 173rd index, 1136 index, 1116th index. So all of this index having the balance column values which are greater than the upper limit, that is 2193. As you can obviously see from here also that the values are 2205, 2499, 2502, which are obviously greater than 2193. Now we may see also that we also can count the values which are actually present in this default column. Okay. Now if I just give df and default, if I give default, that means it is giving us the column name. So df default, that means it is going to give us the column, default column from the df data set. And then if I use dot count, then it will give us the number of defaulters present, or number of observations or data points present in the default column in the df data set. So there are 31 total data points present in the df data set. That means there are total 31 outliers in the entire 31 data set and outliers in the entire data set. Okay. So I may normalize it also to find out the proportion. Now as you can see, if I want to count the values, that how many are ones and how many are zeros in the default column of the df data set. If I want to find out from the default column of the df data set that how many ones are there in the default column and how many zeros are there in the default column, we may just use dot value counts. Now as you can see that if I just want to as, in the original default.csv data frame, there are only 3033 defaulters, but in outliers, there are 26 defaulters out of 31. So we can't remove the outliers directly because it will create a biasness that because there are just only 333 defaulters in the entire data set, and out of the outliers, there are 26 defaulters. So it is not appropriate to remove these outliers. So we can't remove the outliers directly, and we will convert the value of outliers as maximum values. Okay. That means the upper limit. We will convert the value of the outliers as the upper limit. For that we are assigning it there's default dot balance. Here it is used for modifying the present column in the data set. So for that we are going to np, which is the alias for numpy, where default balance is greater than UL, that means which is the outlier. The balance column of the default data set, which is the outlier, that means which is greater than UL, will be converted into UL. For that I am just giving UL again, and it will be stored in our column default within the third bracket balance. Okay, here if the value is higher than UL, then the value will be converted as in the UL value. Let's check whether there is any outlier present in the balance column now or not. As you can see, if I now plot the SNS dot box plot y equals to default dot balance, there is no outlier present. As you can see from the box plot, there is no outlier present here. Now here are some other operations that we have to do. We have to convert this default column as uh, category. For that, I have to just use dot as type category. Here default dot default. It is being taken for modification of the existing column, and I have to just extract the column and then I have to convert it as category, and then I have to just assign it codes, that is 0 and 1. For that, I will use dot cat codes. Similarly, the student column will also be converted into category and then converted into 0 and 1. For that, I am assigning dot cat codes. Now, as you can see, our entire modification is complete. Now we are going to run the regression. For that, I am going to import the scalar dot model selection import train test split. Within X, I am just, X is basically the set of our independent variables. So our independent variables will be all of the variables except the default column. So I am just as dropping the default column, and that means all of the variables will be in the X except the default column, and Y will be nothing but our dependent variable, which is nothing but the default column. So Y is default of, within third bracket, quotation, default. Now X train, X test, Y train, Y test. Okay, so there are the four train. There is a training set of X, testing set of X, training set of Y, testing set of Y. And for assigning this training set and testing set, I have to use this train test split, which is imported from the scalar model selection. And here I am going to assign the values of X and Y, which are nothing but our dependent and independent variables. Test size is 0.3, that means 30% of our entire data points will be in the test set, and the remaining data sets will be on the um, train set. So X train dot shape, as you can see, 7,000 comma 3. That means what is the shape of our training set? Training set is consisting up with 7,000 observations. That means 70% of the entire sample is in the training set, and the 13% is in the test set. You can see that 13% of what is 13%? 13% of 1,000, 10,000 is nothing but 3,000. So 3,000 observations are in the test set, and 7,000 observations are in the training set. Now, if I want to value the count the values and proportion it, then I may just use the normalized true. It is also mentioned before. Now, for doing the regression, we will increase this 3%. As you can see that 97% values are non-defaulters in both Y training and Y testing set. Okay, let me show this. When we are taking the proportion, as you can see, in the training set, 97% are non-defaulters, and in the test set also 97% values are non-defaulters in both Y training and Y test. Now we will increase the 3% of defaulters. There are 3% defaulters obviously in Y training set and Y testing set. There are 3% defaulters only. We will increase this 3% of defaulters in both the sets, because that is required for a proper efficient testing. Okay. If we do test with only 3% defaulters present in training and test set, then the results will be inaccurate. So we will include some dummy values to do it. We will use smooth for it. So we are going to import the smooth from the imb.learn.oversampling. We are going to import this smooth. Smooth is a synthetic minority oversampling technique which will reduce the minority. Okay, so sm equals to, we are assigning a new variable name called sm, and within sm I am going to give this mode function, and within the mode function I am going to give random state equals to 33 and sampling strategy equals to 0.75. That means sampling strategy is 0.75. It is very important. 75% means it will take 3 defaulters for every 4 non-defaulters. Okay. At first there were total 3 defaulters and 97 non-defaulters. But whenever I am using this sampling strategy, it is reducing the minority and it is taking 3 defaulters in the Y train and Y test for every 4 non-defaulters. And by this method, we may find out X residual and Y residual, that is X trace and Y trace, name of our variables. SM, that is the variable that we have or the values that we have stored from using this mode function, sm dot fit sample or fit resample, and we are going to take the X train and Y train in the resample. Now, as you can see, if we give the X rays dot Y rays, this is nothing but the previous code X train Y train. And from the sklearn.linear model, we are going to import the logistic regression now. And we are passing the logistic regression and the function in code that is or in a variable called LR. And by using this LR, we are going to feed LR.feed X rays and Y rays. Now we may predict Y by using the X test. Okay, so that is nothing but Y pred equals to LR.predict X test. Here, from the sklearn.matrix, we are going to import confusion matrix and classification report. This is very much important because this confusion matrix is going to give us the values. This Y prediction is the predicted Y values, and Y test that we are going to obtain is actually the actual Y values. Obviously, actual Y values was from the actual model or from the actual data set. That means Y is the value of the defaulters. Y is the defaulter column. So Y is basically our dependent variable. Now that is the value of the dependent variable from the actual column is the Y test, and Y pred is nothing but the predicted value of Y for each X or each X of the testing set. Okay, now we may find out the confusion matrix from this Y test and Y pred, and this is our matrix, and we have to just add the diagonal terms and divide 2535 plus 77 and divide it by 376 plus 12. The value we have that we have obtained here is the value of R square. You may call it the value of R square. The confusion matrix is used here for giving us the value of R square, and that is showing that 87% of the variation of the dependent variable can be explained by the trained plane, or 87% of the variation of the dependent variable can be explained by the independent variables. So that is showing that it is a good result. Obviously, it is a good result. Here is this confusion matrix that we have imported from the sklearn dot matrix. It is very important because this is going to give us the value of R square, and the prediction of Y done on the basis of testing set of X is also very important. Before that, we have to feed the X rays and Y rays, and for X rays and Y rays, fitting the X rays and Y rays, we have to feed the resample of X train and Y train, and X train and Y train is obtained from the previous step where we have used this mode, but I am not going to tell the function of mode here again. But X10 and Y10 is obtained by this X10 X test, Y10 and Y test from the train test split function that we have used. Thank you for today's video, watching today's video.